Hey friends, how you doing? It's Marisa here with the Santa Cruz Museum of Natural History, and gosh, boy, it's been a week, huh? It's been a day, it's been a year. Um, as you probably know, our Santa Cruz community is going through a hard time right now, and it's gotten worse over the past few hours and days, following what's already been a kind of overwhelming time for us, right? Uh, And really, in the past couple of weeks, there's been also just a series of overwhelming natural phenomena around the area, from bioluminescent phytoplankton, humpback whale washing ashore at Rio del Mar. Also, you've got a freak summer storm that brought hours of thunder and lightning and intense winds, and also subsequent lightning induced fires. And that's what we've been dealing with as of late. Those fires have picked up. And a lot of our community members have been directly impacted by this. Tens of thousands of them have been evacuated from their homes. And even for me, where I am in Santa Cruz, really close to the coast, you can practically see the ocean from where I am. I'm still reminded of the devastation that's surrounding us by the sepia toned skies and the showers of ash that keep falling. And so I just wanted to take a moment to acknowledge that it's a tough time for us out there right now, and our hearts are with our community. And we really did debate whether or not we wanted to have a Rockin' pop-up today. Our Rockin' pop-ups are a fun, bright spot of our week. We have a lot of fun and a lot of laughs talking with Gavin and Graham, the geology gents, about rocks. And we just kind of wondered whether or not it was appropriate for us to do that this week. And what we're doing this week is we are looking back on 115 years of the museum's history. We're celebrating our birthday this week on Friday. And today's Rockin' Pop-Up is all about looking back on 115 years of geologic impacts in Santa Cruz. And when we think about geology, oftentimes we speak in terms of thousands of years and millions of years, but a lot can happen in a short period of time, usually because of these really punctuated high energy moments. So that was our plan for today. And we are going to be talking about some natural disasters that have impacted Santa Cruz. And so we thought that it was appropriate for us to do that today, as our community is also impacted by a natural disaster in its own right, with wildfires impacting our community. And the reason why we want to do that is because that's our job as the museum, and that's what we've been doing for the past 115 years, is helping our community understand it's your natural environment. So we're going to do that today, and we are going to have some fun with it. Consider this a bright spot in your day and a distraction from what's going on outside. So without further ado, I want to bring in the geology gents and ask them to put a smile on our face. Can you guys do that?
We'll do our best.
Great. Thanks, guys. Take it away.
All right.
Yeah, fires are one of those punctuated events, right, Graham? And so it's an interesting time to think about how fires are changing the landscapes. And we have a few landscape evolution things that we're going to be talking about in this pop-up. And fires are one of those natural events, right? It's actually very good for a forest to burn and very natural for a forest to burn. And so oftentimes a lot of the changes we see are brought on by fires, right?
That's right. And so, we live on a dynamic Earth that is a dynamic environment. And, we often talk about geology as these, slow evolutions over tens of thousands, hundreds of thousands, millions of years. But once you really start to zoom in and get to that 100-year level, a lot of the geology that happens there are these big events. And though not necessarily a geologic event, fires are these big, ecosystem overturns that a lot of these forests are adapted to do, but that makes them, no less destructive, and the effects of them, no less powerful. And by the time we get to the end of this, what we'll actually end talking about will be something that actually really relates back to some of the feedbacks that geologic processes have with forest fires. But to start things off, Gavin, I was thinking we might cool down a little bit by heading to the coast.
Yes, Graham. And, I think coastal erosion is a really good place to start when we're talking about Santa Cruz's history, right? In 115 years, Santa Cruz actually changes a lot. And it really comes down to the fact that we live in an area that erosion is happening on a daily basis. And coastal erosion, as we talked about last week, is really forming our environments here. And so this is also a really good feature to start, the one you show on this slide. I think the iconic Santa Cruz features, and one of them are its natural bridges. And so here's a natural bridge, and in a human lifetime, in the lifetime of the museum, actually, you go from having bridges to having no bridges and having a pocket beach instead.
Yeah, and so Gavin, I think it would be great if we could just go through the process of this, and we talked about it a little bit last week, so this will be review for some, and if you're missed us last week, maybe you'll be learning this for the first time today. But how do these natural bridges form? And it all has to do with, you guessed it, waves, right? They're breaking up against these rocks, and when we get a part of the coastline that's sticking out, we call it a point. Those points are places that the energy of a wave kind of gets caught on. And so we call this refraction, and that's when things bend in space as they're moving. But really what's happening is these waves are hitting on the side of these bridges, and they're refracting around them, and it makes them just kind of wrap around, and they actually have some amount of energy that just wraps all the way back around and hits them back in the middle. So over time, you start to erode out these caves that make arches, and then those sea arches can eventually get faults and joints in them. And Gavin, then what happens to our bridges?
Well, the bridges fall, Graham. The bridges are a transient feature for sure. And so it's really just such an interesting thing, because the pictures you have here on the right are from our very sort of famous beach, Natural Bridges State Beach. And so if you travel to the beach today, you'd see the image, something like the image on top, where you have this one natural bridge. But in the museum's lifetime, there used to be two natural bridges. And so the process that you were just describing happened where we had that first bridge, on the left there, form, and over time it thinned and got bigger, and then, as you said, it drops. But at least the bridge that's on the seaward side of this is also sort of becoming more prominent. So the natural bridges name still holds.
Thank goodness for that. Yeah, always a bridge there, at least for now. And who knows, we may have no bridges for a little bit while a new one forms.
That's right.
Those will be things to look forward to. And certainly the natural bridges aren't the only arches we know of around here. There's one now extinct arch from Woodrow and Westcliff that you can even see just how quickly this stuff is happening, how it thins from this picture in around 1890 to 1900. You're losing probably at least a foot or two of rock from beneath there. I certainly would feel comfortable lounging on this bridge, but that one looks a little thin to me, Gavin.
That's right. Maybe I'm not enough of a daredevil to stand on top of such a thin bridge, but it really is a good point to be made, Graham, that even over 10 years, these geologic phenomena are changing, and it's probably not changing sort of gradually. What's happening is that you have some punctuated events, probably storms in the case of these arches, that are breaking off chunks of the bridge once every couple of years when you get a big enough storm. So these are punctuated events that are both making and taking away these features.
Yeah, it's really fascinating how it actually is these kind of high energy moments. And we also recognize how quickly this can be when we think about the original Santa Cruz Lighthouse. And so this is out at Santa Cruz Point, and when it was first lit in 1870, it actually wasn't too far from where it is today. But 8 years later, folks realized, gosh, those cliffs are getting worked away pretty quickly. So they actually moved the lighthouse further inland.
That's right, Graham. Yeah, I think that they forgot to consult a geologist when they were building the lighthouse the first time. And it just so happened that there were some sea caves forming where the lighthouse was. And so it turns out that humans are not exempt from thinking about geology sometimes, especially when they're building buildings. And so 8 years after they built it, they moved it, which seemed to be a smart idea.
It was a smart idea. And you know, this kind of reflects one of those big challenges, is that like geologic thinking it's a trained skill. We often take our, you know, the how fixed things on Earth seem to be for granted, and it can be kind of surprising then sometimes when these things shift suddenly. But the lighthouse survived for a while at its you know, its more inland location, but then was rebuilt in 1965, a little bit closer to where it was originally. But still to this day, there's coastal erosion going on, and who knows, within our lifetimes, we might see that lighthouse moved again.
That's right, Graham. So now we have ways of combating that coastal erosion, but it's always something that we're thinking about. And so, yeah, I'm glad that you brought this picture up, because this is one of the ways that we try and slow the erosion that's happening on the coast. And so what's going on here, Graham?
Yeah, so this is something we call riprap. And there are these great big boulders that we use to fortify sea cliffs or riverbanks. And it's just a way of saying, you know what, these cliffs are a little bit soft when it comes to how the waves are breaking into them. So let's just pile up a bunch of harder rocks in front of them. And that actually ends up doing a really good job of strengthening these sea cliffs. And so you don't have to walk very far along West Cliff to catch sight of some of these, you know, great big boulders that were set into place and have done a really good job in some places, and already in other places, really active wave erosion has helped to wear them down and even, scoot them around. And so, right, like when we're dealing with erosion like this, it is an ongoing work to keep protecting these coastlines, especially when we are in a warming climate that has rising sea levels.
That's right, Graham.
And so, you know, when we talk about coastal erosion, we can't just talk about where the cliffs are getting eroded, because that's not the only thing that's happening. And erosion, when we use the term erosion, we often think about things getting broken down or moved away, but erosion also can put things into place, right? Wherever you take sediment, you got to put it somewhere. And those somewheres are where we have our beaches, right, Gavin?
That's right, Graham. Yeah. And this kind of ties into what we talked about last week when we were talking about coastal landscapes. And so Santa Cruz is known for having some pretty cool beaches, but in the lifetime of the museum, just in the past 115 years, it turns out those beaches have changed drastically. And so you have this picture down here, which I love because it's a beach with what looks like a castle on it. Graham, where is that? I don't recognize that from Santa Cruz at all.
This is but a stone's throw away from the museum, Gavin. This is Castle Beach, which I now know as Seabright Beach, which is, you know, I could, you know, lay on my side and roll down a hill from the museum and I would be there.
That's right, Graham. And, you know, besides the fact that there's a castle there, it also looks a little bit different to me. There's less beach there. Is that right?
That's right. You know, when we head down to Seabright Beach, we go look towards the boardwalk and the San Lorenzo mouth, and we see a huge wide expanse of sand, just like you can see in this satellite image here. But that is an occurrence. The construction of that beach is a sort of natural event that happened within the lifetime of the museum. And it all started when this started coming into town. Gavin, what's going on here?
Well, Graham, that looks like a rocky edifice that is being built out from the beach. And so we call those jetties. And again, this is not really familiar to me when I think of Santa Cruz landscapes. So this must be the start of something being built, right? And so you have this red dot here, and I think we're going to go through and you're going to tell me what's happening in this area.
That's right. So this was the beginning of the construction of the harbor. And so keep this dot in mind, keep what this beach looks like here. We've just got this, little bit of a new jetty reaching out here. After the harbor was built, we saw a sudden growth. The sand around Twin Lakes Beach started getting really deep, covered up all these great big pylons from before. And today, this is what it looks like now. This red dot is in that same place up against that sea cliff. And we've built out hundreds of feet of beach out along that jetty as that long shore current has piled sand up along the shore there.
That's right, Graham. This is a really good interplay between human activity and geology. And I think that's a theme of the past 100 years, because geology is changing so much and humans are trying to live and exist within those changes.
That's right. And so we're trying to set ourselves down and make a living here in this changing environment. So there's often a little bit of wiggling back and forth as the environment shifts, and we try and shift along with it. And so we see the same sort of beach growth happening in Capitola, where over the course of the last about 100 years, quite a large beach has grown out. But sometimes those beaches overgrow, right, Gavin?
That's right. There can be too much of a good thing, even when it comes to beaches. And so here, again, I like the schematic you have in the top left here, Graham. And this goes along with what we were talking about last week, again, with building beaches. And so we have those onshore currents that are taking a bunch of sediments from the rivers up north, and also everything that's eroding off the sea cliffs. And they're bringing all of those sediments up. And when they hit those jetties, they're dropping all of their sand. But we have other things going on the shoreline, and we don't need all of that sand, right? We can sort of plug up the San Lorenzo and cause flooding, or plug up the harbor. And so, Graham, this bottom left picture shows what happens when you plug up the San Lorenzo, right? We have a pretty big amusement park there, right?
That's right. And you get these big outbursts, floods that can happen around the lagoon. And so to keep ourselves safe from that, we dredge. And dredging is where we basically take a big shovel and bucket out into the harbor or around the lagoon and scoop up that sand and help clear it out so that we can easily flush waters back out of the river or out of the harbor and have easy access for those boats. And so that's a bit of good time down at the coast. What do you say we head up onto the hill and think about some of our rock rocks, right? Some of the geologic resources that have been a really key part of Santa Cruz's history.
That sounds great, Graham. And as the geology gents, we got to talk about the geology. And Santa Cruz has such a diverse set of geologic occurrences happening. And so here are a couple of notable things that are happening up close to campus. We know that on campus there are several quarries, and what those quarries are limestone quarries, or marble quarries, more accurately. And so at some point in Santa Cruz history, people were quarrying out the marble, and they were using that marble for one of the components inside of it. So marble is metamorphosed limestone. One of the components of limestone is lime, which is a construction term, and it's one of the ingredients that goes into cement. And so these marble quarries were quarried for lime, and the lime was railed up to Davenport and to the Davenport Cement Factory, which was a big manufacturer of cement. And so, Graham, you have these what look like kilns on the bottom right. Can you talk about how those fit into this whole story?
Yeah, definitely. So you've got this truck here with lots of great marble coming out of one of the quarries, like you can see up on the Santa Cruz campus, the UCSC campus today. And then they take these big piles of marble and they shovel them into these kilns, and they heat up the marble. They get it really, really hot to turn that marble into lime for making concrete. And in order to get that marble so hot, they needed some fuel to heat those kilns. And they recognized fuel where they saw it, because this whole meadow up on the UCSC campus used to be a redwood forest. And so they recognized this abundance of fuel around them, and they deforested the whole area to feed those kilns. And today we still have the meadow because after the lime kilns ended up getting shut down, folks kept grazing cattle up there. So if those cattle were to be sent somewhere else to go frolic in the pasture, we'd actually have a redwood forest up there again. But that meadow actually holds on to that memory of deforestation because those cattle moved in and helped keep things chopped down, and the grass is short.
That's really interesting, Graham. And so a lot of what we see today, the features, some of the man-made features like the kilns that are left behind in our forests, the quarries, those are all a remnant of this interesting story that happened in the past 115 years, right?
That's right. It's sort of this very interesting way of how folks respond to the landscape, and then the landscape responds to the people, and there's this back and forth that helps to shape what we see around us. And so, this is a lot of great stuff about Santa Cruz. We can actually zoom out a little bit with this next topic, which is a very California topic, but an important one nonetheless. Earthquakes. We're in a place that's super geologically active, Gavin. And so we talk about earthquakes a lot, but what exactly is an earthquake?
Well, Graham, an earthquake is an event that happens when a major fault system moves past each other. And so this is a good theme of our Rockin' pop-up today, these pretty quick punctuated events, right? And there's no quicker, more punctuated event than an earthquake. And I'm sure that the audience, especially those who have lived in Santa Cruz for a long period of time, can remember a specific earthquake that made a lot of change to the landscape, right, Graham? But that wasn't the only one in the lifetime of the museum, apparently.
That's right. So there was one earthquake that that is in the history books here in California, that was before the museum's time, but just within our 115 years of the museum, there was a San Francisco earthquake of 1906, which was a very very violent earthquake, and one that was, even more intense than the more familiar one we know here, which is the 1989 Loma Prieta. And so that one we do know was a very sudden and violent event. It was a 6.9 magnitude compared to the San Francisco of 1906, 7.9. But it really caused a lot of damage here because it was so much closer, right up along that fault bend in the Santa Cruz Mountains.
That's right, Graham. And so the reason that we get earthquakes in this area is our very familiar friend, the San Andreas Fault. And the Loma Prieta caused a lot of damage to Santa Cruz because it happened just up in the Santa Cruz Mountains, as you said. So it was a 6.9, and people really felt it downtown. It caused a lot of destruction. And I think that if we talk about maybe the biggest geologic event in the museum's history, this might have been the most dramatic, right?
I think so. And something wild about earthquakes, though, is that because we know they're around here, we start to recognize the importance of these faults, and then we can actually use them to help us, avoid dangerous situations around earthquakes. And that both means how we build structures, where we build structures, and there's no better example than the almost Davenport nuclear power plant that was going to be built down here in Davenport, not too far away from where we know the San Gregorio fault zone to be. But the thing that kept it from being built was the recognition of this key little fault here. So Gavin, tell us about this small and inconspicuous little fault.
Geologic success story, because some really keen geologists were walking around this area in 1972, and they realized that the El Nino storms had washed away a part of the coast. And so they got to look at some fresh new coastline, which are the areas that you have in these pictures. And these geologists were really, really, as I said, they were keen, they were observing, and they realized, well, we see faults in these hills, right? They called it the Frijoles Fault. You could still see it today. And they did some geochronology and realized that these faults must have been moving in the past 10,000 years. And I don't know about you, but it makes a lot of sense to me that you don't want to put a nuclear power plant on an tectonically active area.
Goodness, no. And fortunately, those keen-eyed geologists recognize that and we're able to prevent that from being built so we can rest a little bit more easy, knowing that that's not a threat to us out there. And another neat thing about earthquakes is that sometimes we can feel earthquakes across an ocean. And we saw this happen in 2011 with a very large earthquake in Japan that generated a tsunami that ended up causing quite a bit of damage to the harbor all the way across the ocean.
Yeah, Graham, this was actually news to me. I had never heard about the 2011 tsunami that caused some damage in the Santa Cruz harbor, but sure enough, you had a big earthquake in Japan. Those waves traveled across the ocean and they hit into the harbor, and it turns out it wasn't a good day to be a boat in the Santa Cruz harbor. And there are some really neat papers, some really neat peer-reviewed papers that looked at how this wave energy traveled through the harbor, caused erosion, and how the currents worked. And it was really cool because they used in their paper a lot of the observations of the Santa Cruz residents who were taking pictures and videos of the tsunami as it was going on. And it turns out there were things for us to learn about that.
Yeah, a cool, moment in time where civilian science and citizen science really came in to help understand a geologic event. And this really helps to show how intertwined the water on Earth and the rocks on Earth really interact with one another. And certainly water played a big role when we think about the San Lorenzo and how it used to be pretty common for the San Lorenzo to flood. And it was really kind of a final straw for the Santa Cruz community in 1955 when a great big flood, there was a huge flood of the San Lorenzo, and in response, we built these levees. And so in this modern picture, you can see this well built up levee system around here. But before, it's a pretty flat goodness gracious, a pretty flat floodplain without those levees.
Say that 5 times fast.
My goodness, I know. And so you can even see when we look at a picture of a pretty similar stretch of river in Santa Cruz, how much the banks of that river had been built up. And those serve to help protect us, right, Gavin?
That's right, Graham. I'm pretty happy that we had that levee system in 2017, the year after we arrived, because that was actually a very large geologic event, a 100-year event that happened where we got these things called atmospheric rivers, these large, wet air currents that start near Hawaii, travel across the Pacific, and slam right into the side of the coast. And I just could not believe how much it was raining that year. And with a lot of rain comes surging San Lorenzo. And even with the levee system, it got pretty close to breaching those flood walls. But it turns out that our levee system saved us again.
That's right. That levee system really came in and helped out there. And I remember I used to live real close to the river about that time. And I remember crossing those bridges and saying, whew, thank goodness we've got those levees protecting me and my basement apartment. Great. And so one other thing that came out of 2017, which is something that will be important for us to think and talk about today in light of fires, is when you put all that water into the ground, all those rains, that helps to lubricate the masses of earth up on the steep slopes around the coast here. And that's how we get landslides.
That's right, Graham. And so I think that, you didn't have to travel far to see some pretty big landslides. This is the one that shut down Highway 1, if I remember correctly, right?
Mm-hmm.
So this one is down in Monterey, but I remember you couldn't cross 17, and there were everything from really big landslides like this one to small ones that still shut down roads. And so when we're in a very high topographic area with a lot of mountains and a lot of rains, landslides are, a reality of this situation as well, and one that really affects the landscape and even in the day-to-day lives. And so have to talk about that when you talk about 115 years of geology. But Graham, you mentioned that fires can play a role here. How does that work?
Yeah, and so, these landslides occur in these really steep areas, and we certainly are familiar with steep landscapes here in Santa Cruz. Down in Santa Cruz, we're really, familiar with those stepped marine terraces, but those aren't only those aren't the steepest things around here, because we also have these areas where we've got mountains rising very steeply, and those steep mountain slopes are actually shaped by sort of recurring landslides that work along them. But one thing that they have to hold them in place is trees and plants, and their root systems actually help to serve as anchors. But that's where fires start to really make a difference, is because if they burn up those anchors, then you start to loosen up that dirt. And so one of the hypotheses that went into this Big Sur landslide was that fires in some previous seasons had actually left the muds and the dirts there a little bit less stable than they had been before, and that actually helped to set off the event.
That's right, Graham. And so again, an interplay between what's going on both geologically and even with things like fires that affect the flora and fauna. And so it really is all about the Earth just being a very dynamic place. And when we think about the Earth on human timescales, we often, as you said, we want to think about it as a stationary thing that we just build up on, but we have to remember that the Earth moves around and settles down and things like that. And so these are we're seeing the effects.
Yeah, I agree. It's a dynamic place to live, but it's also our home.
That's right. 115 years of geology. A lot of stuff happens in that amount of time. So good for the museum that saw it all.
Yeah, well, thanks for celebrating those 115 years with us, Gavin and Graham, and for sharing some of these milestone events that have occurred within that history, and that the museum has interpreted for the public and for our community for all that time. A lot of the milestones that you've highlighted today are things that I know, even within my own short tenure with the museum, we've talked about. We're working on an exhibit right now about Castle Beach, which I think people also know as Fresno Beach and Seabright Beach and Twin Lake State Beach. And some of the images that you showed of the eroding coastline at natural bridges and other places along the coast were featured in an exhibit that we had a couple of years ago called Rocks and Waves, where we talked about the eroding coastline along Westcliff Drive. And so that's what the museum does, is we interpret our natural environment for our community, and we help connect our community with nature in a lot of different ways, whether it be by celebrating natural wonders or by getting a little bit more familiar with some of the aspects that may be a little bit more unsettling from time to time. So thanks to you guys, Gavin and Graham, for being a part of that as well through sharing the geology of our region with our community. We did have a question about the 1989 earthquake coming through the comments. Someone is maybe a little concerned that maybe we haven't had enough earthquakes since then. And does that mean that we've got another one coming? What do you guys think about that?
That's the age-old question when it comes to earthquakes. And geologists, especially seismologists, spend their whole careers trying to figure out ways that we could possibly try to understand when the next one's coming. And it really just is a hard thing to do. And so we can't really predict when there's going to be one. I don't even really feel comfortable saying that since there hasn't been one, that means there's going to be one soon. It really kind of is up to the Earth when it wants to move. Right, Graham? Would you agree with that?
That's right. One thing we can say for sure is there will be another earthquake, but the when is this classic geologic conundrum. One good news is that our ability to sense the tremors beforehand are much better than they were in 1989. So we don't have great warning systems. That's what folks are always working on. We're always trying to get like forecasting and like really far out warning systems. that we're generally better able to predict them. And so that's something to, feel comforted by. But we're still in a place where we couldn't say if it'll happen a year from now or, 100 years from now. And so it's a tricky one, but some of the brightest seismologists out there are doing their best to get even better, things in place.
Yeah. And last year we were looking back on 30 years since the Loma Prieta earthquake. And I know that you, Gavin and Graham, helped us out with that, as well as some of your colleagues from the seismology lab at UC Santa Cruz. And this question came up a lot during that that time when we were looking back on 30 years since that earthquake. And I do remember Heather from the seismology lab sharing that the fact that we had the 1989 earthquake means that it's probably unlikely that it's going to happen again anytime soon, because what happens when you have a major earthquake like that is that there's so much buildup stress that it just like snaps, which is maybe not the exact right word for it, but we've released all of that built up energy along that one part of the fault at least. So that's a good sign. That's something to hold on to when there's so little to hold on to right now. Yeah, so also I just want to take a moment to share with our community joining us today that like we've been talking about, the museum turns 115 years old this week. On Friday, it was August 21st, 1905 that the museum first opened its doors. And even though our doors aren't open right now, we are still eager to connect our community with nature. And so we're going to be looking back on that long history, sharing some updates from the museum, and also looking forward to the future on Friday. So I'm going to share a link for that event in the comments, and I hope you all can join us and celebrate this long running institution that has done so much for our community, and that is eternal. It'll continue to serve this community long after me and Gavin and Graham are gone. So thanks for joining us for this. We hope that you all are safe, that you are well, that you are able to breathe easy, and that our community is alleviated from this major hardship soon. So be safe out there, everyone, and thanks for being with us.